Howdy! Welcome to Aspire Mount Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice using linear regression analysis to solve a problem involving predictions. Let's get started. So we're going to look at an example problem involving bids in an auction house. So here we have a table with data that's listing the opening bid for 5 randomly selected items and then the actual winning bid that actually won the item from the auction. So with this data in mind, we're going to answer the following questions. Assuming that a linear correlation exists, what is the linear regression equation? 2, what is the best estimate of the winning bid for an opening bid of $500? And 3, is this best estimate close to the actual value of $750? This data should be in our class group in StatCrunch, so you shouldn't need to type it in if you want to follow along in StatCrunch. Just go to StatCrunch and open the data file from our group, and you should have it there in StatCrunch so you can follow along. The first question we're asked is, assuming that linear correlation exists, what is the linear regression equation? Well, that's easy enough to get. We just put the data into StatCrunch, go to Stat, Regression, Simple Linear. Identify the columns so StatCrunch knows where the data's at. Press Compute, and out comes your results. The regression equation is located right up here at the top. Now, sometimes that gets to be kind of hard for, I know sometimes it's hard for me to see. Maybe it's hard for you to see sometimes too. It's because there's a lot of business going on at the top part of your results window. So notice how we've got the same equation here, 75.83. Notice that in the parameter estimates table, we've got the same values here for the intercept and for the slope. So I often take these values here from the parameter estimates table, and that way I can actually see them better and I avoid transcription errors. So this area right here has got the same numbers as our regression equation itself. Either way you get it, you can come to the same conclusion of the regression model. Now, what is the best estimate of the winning bid for an opening bid of $500? Well, to do that, we can use our regression equation. First, we need to know if our model is good enough to use to make predictions. So let's compare with our critical R value to answer that question. Here's our critical R value table, or rather a snippet from it. And we've got 5 pairs of data, and we're looking at a 5% significance level. So that means 0.878 is going to be our critical R value. The R value we get from our data is 0.947. So we're going to clear the bar, and that means our model is good enough for making predictions because we have statistical evidence of linear correlation. The other way to get to that same conclusion is with the p-value. Just compare it with alpha. So when we do that, we see that yes, we can fit that area for the p-value inside the area for alpha, and that means we're inside the region of rejection. We reject the null hypothesis, which says the correlation is 0, which means there's no correlation. We say there is correlation, then we can use the model for predictions. Now that we know that the model is good enough to use, we could actually write it out and just do a little bit of quick algebra, but we don't have to calculate this out by hand. StatCrunch will do that heavy lifting for us. So if we go back to our options window, put in the predicted value for the x, 500, then we hit compute, and out comes a predicted value for the y right here. Second value from the left in the predicted values table, which is at the bottom of your results window. So you may have to scroll down a little bit to see it depending upon how your results window is sized. Is this the best estimate close to the actual value of $750? Well, look at the prediction. The prediction is for $1,120. So are we close to 750? I hope you just said no. We're not close to 750. In fact, we're nowhere in the neighborhood. So it seems like this model has its limitations. And one of the things limiting the model is the fact that we've only got 5 data points. We need a much, much larger sample size. And with more data, we can increase the predictive ability of our model. We can refine it so that the predictions get closer to actual values. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.